Okay, so let's talk about verifying, okay? So verifying, when we are verifying, we have a couple of big principles that we want to remember. The first thing is pick one side of your equation, the more complicated side, to work with, okay? So in this case, which is more complicated, cosine squared x or cosecant x cosine x divided by tangent x cotangent of x? I would definitely say this side is more complicated. So we're going to focus on the more complicated side, and we're going to apply various techniques to try and make this look like cosine squared of x, okay? Now, what are those techniques? Well, we have a couple of different techniques. One is to change everything to sines and cosines, okay? Another is to apply general algebraic principles. So get a common denominator and combine terms. Distribute or factor as needed. Another is to think about common identities. So things like we may need to use reciprocal identities. We may need to use Pythagorean identities, things like that, okay? So we already picked the side we're going to work with, the more complicated side. Now here, right, I've already got everything as one term, so I don't need to use algebra to get a common denominator and combine things. Probably my best bet here is going to be to change everything to sines and cosines, okay? So each term I'm going to change into a sine and a cosine. So cosecant of x, using a reciprocal identity, cosecant is 1 over sine. So I'm going to rewrite cosecant as 1 over sine. Cosine is already in terms of cosine, so I'm going to leave cosine as it is. So there's my numerator. If it helps, I may want to think of cosine as cosine over 1. That's just going to let me see how I can combine things easier in the numerator. On the bottom, okay, I have tangent. Tangent is sine of x over cosine of x. That's a quotient identity. Cotangent is cosine over sine, also a quotient identity. Okay, now what? Now it almost looks like we've made things more complicated. That's all right, because we're kind of working our way into where we hopefully get cancellation. So now what I'm going to do is I'm going to look at my numerator and my denominator separately. So I'm going to start looking at my numerator. Well, my numerator is fairly easy to now combine into one thing. This is multiplication of fractions, so I multiply across the top to get cosine of x over on the bottom sine of x. So here's my numerator. Okay. Now let's look at what's going on the bottom. On the bottom, I have addition. I have sine of x over cosine of x plus cosine of x over sine of x. To combine those together, I need to get a common denominator. My common denominator will be cosine times sine. So that means here I need to multiply top and bottom by sine. So that gives me sine of x times sine of x is sine squared of x over cosine times sine. On this guy, I'm going to have to multiply top and bottom by cosine. So cosine of x over cosine of x. On top, cosine times cosine is cosine squared. All over on the bottom, I'll have sine times cosine. I can write that in a different order and say cosine times sine. Okay. So now I have the common denominator, cosine, sine. I can combine those together to get sine squared of x plus cosine squared of x over cosine x sine of x. That's all part of my bigger fraction here. So my numerator is cosine of x over sine of x. My denominator is sine squared plus cosine squared of x divided by cosine x sine of x, okay? Now what we're going to do is we're going to use fraction properties to say dividing fractions is the same thing as multiplying by reciprocal. At this point, if you recognize sine squared plus cosine squared as a Pythagorean identity, sine squared plus cosine squared is 1, you can take this whole term and rewrite it as 1. I'm going to go ahead and do that, mostly because it's going to be less for me to continue to copy. Okay, so where are we? I'm going to move back down here. We have in the numerator cosine of x divided by sine of x. We are dividing that by our denominator, which is 1. Sine squared plus cosine squared is 1. So 1 over cosine x sine of x. When we divide fractions, it's the same thing as multiplying by the reciprocal. So this is the same thing as cosine x over sine x times cosine x sine x over 1. Dividing by this is the same thing as multiplying by the reciprocal. And now I'm going to look at, can I do any canceling top and bottom? We'll have a sine on bottom and a sine on top. So that just leaves me with a cosine times cosine on top, which is cosine squared, which is exactly what we wanted. So we're done. Notice what techniques we used. We picked the more complicated half to simplify. We rewrote everything in terms of sines and cosines. We used algebra to combine our numerator, so you just by algebra fractions, multiplication of fractions, okay? On the bottom, we had to use an algebraic technique. We had to get a common denominator so we could combine these together into one term. We used a Pythagorean identity here to rewrite sine squared plus cosine squared as 1. And then again, we used some algebra techniques, dividing fraction, multiplying by the reciprocal to do some canceling to get where we wanted to go, okay? So those are our big techniques with verifying, right? Pick the more complicated side. And then you're going to simplify that as much as you can by doing things like rewriting with sine and cosine, using algebraic techniques, looking for common identities, Pythagorean identities, things like that, okay? There's lots of different ways, there's lots of different verifies, but those techniques will work to get us where we want to go, okay? Now, I do want to do a contrast with the verify. So this is a verify. Notice when we're verifying, we have something equals something else. I do want to contrast that with a simplify. When we're given a simplify problem, we don't have an equal sign. So let me put a simplify problem up here to talk about. Okay, so here's a simplify problem. Notice that I don't have the equal sign that I had with a verify. But other than that, we really work simplify problems almost exactly the same way. You don't have to make a choice about which side to work with. There's only one side, this side. So other than that, our technique is the same. The other tricky things with simplifies is, when do you stop? When have you simplified enough? In general, when we're simplifying, we want to get things down so we don't have any fractions. So no fractions, so nothing in a denominator. And we also only want one term, so I don't want any addition and subtraction if possible, maybe some multiplication, so I could have like a sine times a cosine, but I want to get things in as few terms as possible, and I don't want any subtraction or addition, and I don't want any division, okay? So let's see if we can do that. Okay, so remember one of our biggest techniques is to rewrite things in terms of sines and cosines. Well, this is in cosine, this is in sine, so let's go ahead and rewrite this tangent. So I'm going to rewrite tangent as sine over cosine. Everything else stayed the same. Okay, so now we're here. Okay. Now notice that I have subtraction and I have fractions. That tells me that I probably need to use a common denominator to combine these into one big term. The common denominator is going to be 1 minus sine times cosine. So here, I'm missing that cosine piece, so I'm going to multiply top and bottom by cosine of x. So that's going to give me cosine times cosine is cosine squared of x over cosine x times 1 minus sine x. Okay. Minus, over here, I'm missing the 1 minus sine piece, so I'm going to multiply top and bottom by 1 minus sine. Okay. I'm going to go ahead and distribute on top, making sure I remember this is a negative, right? So I'll have negative sine times 1 is negative sine. Negative sine times negative sine is positive sine squared. That's my new numerator, all over cosine x times 1 minus sine x. Now, you might be wondering, and it's a really good question, why did I choose to distribute in the numerator and not in the denominator? And the reason is just experience, okay? I'm guessing that we're going to be able to simplify some stuff in the numerator. In other words, use some type of identity, cancel something out, make the numerator simpler. That's really often what happens when we get common denominators and combine the numerators. Denominators, that usually doesn't happen. Instead, what usually happens in the denominators, we're going to look for some cancellation after we've simplified the numerator. Okay, so let's look at where we are. in my numerators, I have cosine squared minus sine plus sine squared. In the denominator, I have cosine of x times 1 minus sine of x. Okay, right now this looks kind of like a complicated mess, but we're getting somewhere. Why are we getting somewhere? Because I notice in my numerator, I've got a cosine squared plus a sine squared. Okay, so if I do a little bit of reordering in my numerator, so all I'm going to do is I'm going to change the order of things in the numerator. I'm going to put cosine squared and sine squared together. So cosine squared of x plus sine squared of x. And then I still have this minus sine of x. All over, I didn't do anything in the denominator. Cosine x, 1 minus sine x. Okay, all right. Well, what is that doing me? What good is that doing me? Well, think Pythagorean identity. When we've got squared things running around, I often want to use the Pythagorean identity. So here, cosine squared plus sine squared is equal to 1. So I can replace cosine squared plus sine squared with 1, which gives me 1 minus sine of x, that's what I have on top, over cosine of x times 1 minus sine of x. Hey, now it looks like we're getting somewhere. Notice that on top I have 1 minus sine of x, and on bottom I have 1 minus sine of x. Those cancel. Those just go away. That leaves me with 1 over cosine of x. That's really close to a final answer, except remember we didn't want any denominators. We didn't want any quotients, anything in fraction form. How can I change 1 over cosine to something that doesn't involve a denominator? Well, think about your reciprocal identities. 1 over cosine is the same thing as secant. Now it doesn't get much simpler than secant, so that is my final answer. I simplified this, cosine of x over 1 minus sine of x minus tangent of x, to just secant of x. Pretty awesome, okay? All right, so that's verifying and simplifying.